Hello and welcome to Scratch Chemistry. This is the part 2 of phenol. In part 1 we discussed about the physical properties of phenol. In this video we are going to discuss about the preparation and reaction of phenol. Okay, so let's get started. So preparation number 1, right? How we can prepare phenol from chlorobenzene, right? From chlorobenzene. Okay, so write some point from chlorobenzene, right? Hydrolysis of chlorobenzene with aqueous sodium hydroxide NaOH with aqueous sodium hydroxide at high temperature and high pressure followed by treatment with dilute acid then we can get phenol from chlorobenzene. So write the reaction. This is the reaction. What is the reaction? Chlorobenzene, structure of chlorobenzene. This is chlorobenzene. Okay, chlorobenzene, the first step we are using aqueous sodium hydroxide, aqueous NaOH at high temperature and high pressure. High temperature here is 350 degrees Celsius and high pressure is 150 atm. Okay, high temperature and high pressure, in the what it will form? It will form O minus here, right? O minus Na plus. Okay, phenoxide ion, sodium phenoxide. In the second step we are using, followed by treatment with dilute acid. So dilute acid, you can take dilute HCl, you will get what? Phenol. Okay, then what is the mechanism of this one? See the mechanism, right? It follows addition elimination reaction. It follows mechanism, right? It follows elimination addition type. Elimination addition type reaction. Okay, so how? See the mechanism here. This is chlorobenzene. Okay, to this chlorobenzene we are using aqueous sodium hydroxide. Since base sodium hydroxide behaves as a base, so it will abstract hydrogen. This is, here is a hydrogen, it will abstract the hydrogen and this bond moves over to this carbon double bond to form carbon triple bond and Cl group releases, and this step is known as elimination step. Elimination of occur, HCl eliminate here. So what it will form? It will form here benzene intermediate formation takes place. This intermediate is known as what? Benzene intermediate. In the next step, the OH minus here, again the OH minus behaves nucleophile here. What? Nucleophile. So OH minus first case here behaves as a base, in the second case behaves as a nucleophile. It will attract to the benzene ring and this bond moves over to this carbon. Okay, mark the finger or mechanism. So what it will form? It will form this bond here, and here double bond also present. Here OH group attached to here. Okay, and here this bond moves over to here negative, as a negative charge. Okay, in the next step what will happen? Okay, in the next step O minus takes the hydrogen from here and this bond moves over to oxygen to form what? O minus, here hydrogen attached, and here O minus, and the other part is Na plus present in the solution. O minus Na plus. Okay, this is the intermediate O minus Na plus. In the next step, if you give dilute acid, means H plus, from acid H plus will be taken by O minus to form phenol. Okay, understood? This mechanism is elimination addition type mechanism. So coming to this is the method 1. Method 2, right? Method 2, from sodium benzene sulphonate. What? Sodium benzene sulphonate. So what is the structure of sodium benzene sulfonate? This is benzene ring, sulfonate, SO3 minus, sodium plus, sodium benzene sulfonate. Similar mechanism if you give aqueous NOH, it will follow the similar mechanism like elimination addition type. Here OH minus takes the hydrogen from here, okay, takes the hydrogen, this one moves over to carbon carbon double bond to form carbon carbon triple bond, and this here SO3 minus Na plus leaves. What it will form? One benzene structure. Okay, in the next step OH minus, here OH minus again behaves as a nucleophile, here base but here nucleophile. OH minus attack to the benzene ring and this bond moves over to this carbon, okay, this carbon particularly. What it will form? Here OH, okay, and here negative charge. In the next step O minus takes the hydrogen from OH and this bond moves over to oxygen, form oxygen negative, O minus, here H. In the next step gives, if you treat this compound with acid, okay, H plus, dilute HCl from dilute HCl, the H plus will be taken by O minus to form phenol, okay. Similar mechanism to previous one. So method 3 for the preparation of phenol, the third method for the preparation of phenol from BDC. BDC is what? Benzene diazonium chloride. Writing, I am writing benzene diazonium chloride, okay. So what is the structure of BDC or benzene diazonium chloride? Here you can see the structure of BDC, benzene diazonium chloride, N2 plus Cl minus. To this, instead of here you are using in the both case aqueous sodium hydroxide, okay, but here we will use water sample, water, and heat the reaction, okay. So from water OH minus here is behaves as a base and takes the hydrogen here, and this bond moves over to carbon carbon double bond to form carbon carbon triple bond, and N2Cl group leads to formation of what? Benzene ring. What ring? Benzene ring. So this is also elimination addition type mechanism through benzene intermediate. Elimination addition, elimination of here HSO3H Na plus elimination occurs and addition OH group addition takes place. So elimination of here what? N2Cl and H takes place, and in the next step here OH minus nucleophile from water add to the benzene ring and this bond moves over to this carbon and leads to formation of what? Here OH, okay. This is what? Phenol, okay. From BDC also elimination addition type to form phenol. Elimination addition, which intermediate? Benzene intermediate, okay. So these are the three methods for the preparation of phenol, okay. I'm sorry, I forgot one thing here. After this, the similar step, H plus or dilute acid from dilute HCl, H plus will be taken by this negative charge to form phenol, okay. Another step I left, H. This is the phenol, okay. So now take a screenshot in your mobile. I will erase the things, okay. Look at this side, the number 4 method for the preparation of phenol, that is from right from cumene hydroperoxide, cumene hydrogen peroxide or hydroperoxide. So cumene hydroperoxide. So what is the structure of cumene first? Structure of cumene, look at this. This is benzene attached to carbon, the carbon attached to 2CH3 group, here one hydrogen. This is the structure of what? Cumene, okay. To this cumene, if you do aerial oxidation in presence of oxygen O2, the reaction undergoes free radical mechanism. Which mechanism? Free radical mechanism. What is the mechanism? See here, O oxygen O double bond O, okay. So this bond breaks in presence of light. So what it will form? O single bond, so one bond breaks, one electron taken by this oxygen and another electron taken by this oxygen, then O dot. All of you got it, okay. This one free radical, oxygen of free radical, one electron takes the hydrogen, take this hydrogen. Okay, why? Because the resultant free radical, and this bond moves over to carbon atom, so it will form what? It will form little, okay, little down. It will form what? One free radical, and this free radical is stable. This is which free radical? Benzyl free radical. Phenyl ring attached to carbon and free radical over this carbon. This is whole total benzyl free radical, and benzyl radical all of you know stable. So that is why this hydrogen is taken by oxygen. So forms free radical. Next step what will happen? The oxygen takes the hydrogen. Then what it will form? This oxygen takes the hydrogen. Oxygen attached to hydrogen. Okay. Now this side only one electron left. So this electron combine with this carbon means benzyl radical. Both the electrons share their electrons and paired up to form what? They form CH3 carbon attached to oxygen, oxygen H, carbon attached to oxygen, oxygen H, and this structure is known as what? Cumene hydroperoxide. What? Cumene hydroperoxide. Okay. So direct step, write this structure here. CH3, let CH3 this side and OOH this side, OOH. All of you got it? Cumene hydroperoxide. In the next step what will happen? Okay, if you give acid, any acid, let us suppose H2SO4, from H2SO4, if H2SO4 dissociates, it will form H plus and HSO4 minus. The H plus will be taken by this oxygen lone pair, takes the hydrogen here to form what? To form CH3, and here oxygen takes the hydrogen by donating its electrons, so positive charge over oxygen. Okay, now this water group is a what? Good living group. So in the next step, water group releases carbon CH3 and oxygen. This water group releases minus water. If water releases, then positive charge over this oxygen. Bond breaks from this position, so positive charge from over this oxygen. So over this oxygen there is positive charge. In the next step what will happen? All of you know positive charge over electronegative element is not stable. So what will happen in the next step? This is the step is a rearrangement step. What step? A rearrangement step. So what it will do? So there are three groups, CH3 group, or you can say NGP, neighboring group participation also. So there are CH3 phenyl ring. So with between CH3 group and phenyl group, which group have more electron density? Obviously phenyl group. Okay, so here is oxygen is electron deficient, it needs more electron. So phenyl group, as it has more electron, okay, it will migrate, this bond will, phenyl group will migrate to this oxygen. Okay, which group migrate? Phenyl group migrate to this oxygen. What it will form? This migrate na. It will form CH3 carbon CH3. Okay, the phenyl group migrate to this oxygen. Okay, so as bond breaks from this carbon atom, okay, then there will be positive charge over this carbon atom as phenyl group lost from this carbon. So now phenyl group now attached to this oxygen, OPH. In phenyl group we can write PH, phenyl for phenyl. The group, then formation of what? Carbocation, and this carbocation is stable. Okay, 2 degree carbocation, and again oxygen electronegative element is attached to that carbocation. This is why, that is why this carbocation is stable and phenyl group migrates. In the next step what will happen? In the next step, if you use water, H plus water, acidic water, what will happen? Water will nucleophile attack to this carbocation. What it will form? C, CH3, CH3, then OH, oxygen addition of water, OHH plus as oxygen donates its electron to this positive charge over this oxygen, then oxygen and pH. Okay, for phenyl I have written pH. So in the next step what will happen, see here the oxygen and this oxygen positive charge over oxygen is not stable, so it will drag the bond electron, OH bond electron towards itself. How? When this oxygen lone pair takes the hydrogen, this bond moves over to oxygen to neutralize oxygen. What it will form then? It will form CH3, CH3, oxygen, and this carbon attached to now OH, oxygen now neutral, and this oxygen takes the hydrogen by donating its electron, then positive charge over this oxygen obviously. Okay, and this oxygen attached to phenyl. Understand? So next step what will happen? See, now the positive charge over this oxygen and it is not stable. What it will do? This bond moves over to carbon oxygen single bond to form carbon oxygen double bond, and this bond moves over to oxygen atom and neutral it. Okay, then there is formation of what? This group what? Carbonyl group means ketone group, CH3 carbonyl CH3. This is which group? Ketone group, CH3. This ketone forms here, plus here is what? PHOH. Okay, PHOH what? Phenol, plus PHOH. PHOH group is what? Phenol group. So write it here, just here, phenol group. We find phenol group. Okay, OH. This is what? Phenol. Okay, all of you got it? PHOH is phenol. Okay, this is phenol ring, and we got ketone also as a byproduct. This is the reaction mechanism for the synthesis of phenol from cumene hydroperoxide. Okay, reaction mechanism again I am saying, we are getting cumene hydroperoxide. This is the starting material, cumene hydroperoxide. So cumene hydroperoxide, how we got? By aerial oxidation of cumene group. We got cumene hydroperoxide by free radical mechanism. Okay, this is the free radical mechanism. Okay, to this cumene hydroxide, if you give acid, H plus will be taken by this oxygen to form OHH water molecule, then releases in the next step to form positive charge over this oxygen atom. In the next step rearrangement occurs, means phenyl group migrate to this electron deficient oxygen atom. Okay, to form OPH, and as bond breaks from this carbon, positive charge over this carbon. In the next step, if you acid hydrolysis this carbocation, it will water group addition to this carbocation OHH. Then in the next step, the deprotonation step, oxygen takes the hydrogen, this bond moves over to oxygen to make it neutral. In the next step, this bond moves over to carbon oxygen single bond to form carbon oxygen double bond, and this bond, particularly this bond, moves over to oxygen to make it neutral. So this side is what? This side PHOH means phenol group, and this side is CH3 C double bond of ketone, phenol plus ketone. We got our desired phenol. Okay, all of you understand? So now comes to its, this is we covered 4 type of method to synthesize phenol. Okay, now comes to different reactions. So if you look at the structure of phenol, there are OH functional group and benzene group. Okay, so for OH there are 3-4 reactions we will study, and for benzene we will study different reactions. So first study the reaction related to OH group in phenol. So give heading reaction related to OH group in phenol. All this under chemical properties of phenol. Okay, so OH group कौन सी reaction देगा? So first reaction, right? Formation of salt. Okay, so all of you know phenol is a acid. So if phenol react with base, it will form definitely salt. So right, as phenol is a acid, it reacts with base to form what? To form salt. Okay, so what are the bases here? We can take base sodium hydroxide, potassium hydroxide, okay, also sodium metal, Na metal. Okay, these are the bases which phenol reacts to form salt. So see the reactions. So phenol structure, this is phenol. Okay, to this if you react with sodium hydroxide, this is acid and this is base, what it will form? Water releases, OH water releases form salt, O minus Na plus, sodium plus water, sodium phenoxide ion. What? This salt name is sodium phenoxide. Okay, so reaction mechanism all of you know. The base will takes the hydrogen from here, then O minus, counterpart here Na plus. Okay, simply. So similarly other reactions, if it reacts with sodium metal, okay, sodium metal, electron configuration of sodium, outer orbital electron configuration of sodium is 3s1, single electron over single electron in the outer orbital of sodium. So for bond formation it needs 2 electrons, so that we should take 2 moles of sodium. Okay, so likewise we should take 2 moles of phenol. It will form what? It will form similar product O minus Na plus. I have already said the mechanism of this one. So it will form again 2 moles of sodium phenoxide and here forms H2 gas releases. Okay, all of you understand? So do you think the phenol, okay, if phenol reacts with sodium carbonate Na2CO3, sodium carbonate or sodium bicarbonate NaHCO3, will it give the same salt? Will it give the same salt, that is sodium phenoxide? Do you think? It will not give the salt. Why? Because phenol is less here CO3, the compound containing carboxylate ion. Okay, and phenol is less acidic than carboxylic acid, that is why it will not form the salt. Okay, so this is the first reaction, that is formation of salt. Then second reaction that phenol undergoes, right, formation of ether. What? Formation of ether. Okay, ether group all of you know. Ether group is ROR dash, and R and R dash are both are any hydrocarbons. Okay, so formation of ether, how? So to this phenol ring we can write it as C6H5OH. This is phenol, C6H5OH. To this phenol, okay, same use sodium hydroxide in the first step. Sodium hydroxide, it will form sodium phenoxide ion, sodium phenoxide, right, C6H5O minus Na plus. Okay, in the next step, okay, in the next step if you will use ethyl chloride, we can write it as CS3CH2Cl, CS3CH2Cl, ethyl chloride or methyl chloride you can take. Okay, so what will do? It will undergo simple substitution reaction, SN2 type reaction, substitution nucleophilic bimolecular type reaction. So here is C6H5O minus is a nucleophile, here this CH2 group is a electrophile and chlorine group is a better living group. Substitution, the nucleophile attack the electrophile here and this Cl group releases. Okay, so what it will form? It will form C6H5O and oxygen now attached to this CH2 and CH3, and chlorine group here releases minus Cl minus. Okay, minus Cl minus, here Na plus, both will combine to form NaCl. Okay, easy. This is the structure of what? Ether. So formation of ether, all of you understand? This is R group, any R dash group, in between there is oxygen. So this is ether. So in the third reaction, phenol undergoes, right, reaction with FeCl3. What? Reaction with Fpcl3, ferric chloride. Okay, so ferric chloride, all of you know, is a Lewis acid. It will accept electron. So write phenol structure here. First, structure of phenol. This is phenol, OH. Okay, FeCl3, Fe3Cl. Okay, so it is a Lewis acid. It has vacant d orbital. It will accept electron. So it behaves as a what? Electrophile, and nucleophile is this oxygen non-bonded electron over oxygen. Okay, so this is nucleophile, iron atom is electrophile, and chlorine group is 3 chlorine groups are living groups. Okay, as there are 3 chlorine groups are living groups, we can take 3 moles of phenol. Okay, then there will be 3 moles of nucleophile. It will attack to iron atom, and it will replace or substitute 3 moles of chlorine atom. Again, the 3 moles of phenol atom molecule, 3 moles of phenol molecule, nucleophile, it will attack the electrophile Fe atom. It will replace 3 moles of chlorine atom. Okay, so what will the product form? See, oxygen, and oxygen attached to now iron, and 3Cl group releases. Okay, substitution type reaction, SN2. This is also SN2 type mechanism, substitution. So 3 phenyl phenoxide ion group now attached to now iron atom. Okay, 3 phenyl phenoxide ion replace 3 chlorine atom. Okay, all of you understand? So in simple mechanism, if 1 mole of OH attack 1 mole of phenol, the oxygen attached to Fe, Cl releases. Another mole of phenol attack to Fe, another Cl releases. Another mole of phenol, the oxygen lone pair attack to Fe, the chlorine group releases. In this way, 3 phenol molecule we are using to replace or substitute 3 chlorine atom to get this complex. This is a complex, and the color of the complex is purple. You can write purple complex. The complex which you will get, it is a purple in color. Okay, these are the 3 type of reactions of OH group of phenol. All of you take a screenshot in your mobile or note it down. Okay, thank you guys. In the next class we will cover the reaction related to the benzene ring. Okay, see you in the next class. Thank you. Stay happy, stay healthy.